Hi, my name is Chase, and today we'll be doing experiments involving static electricity, and my solution to every problem, duct tape. Before we get into doing these experiments, we actually have to answer the question, what is static electricity?
Static electricity is just a buildup of charges on an object, and it's when you have opposite charges that fun stuff begins to happen. There are a lot of common examples of static electricity in our daily lives, one of which is dust. Dust sticks to everything, and the reason is because it's charged. Another is lightning. Lightning itself isn't static electricity, but clouds contain the static, and lightning is just a release. Another example is spray paint. Spray paint uses the charge to stick the color to where it wants to go. And the final example is balloons. We've all seen somebody's hair stand up on end because of balloons. Lightning and clouds are some of my favorite examples of static electricity, because not only are they really cool, but they're also a really good example of how strong static electricity is. Lightning is very similar to what we see when we rub our feet on carpet and shock somebody. It's just way bigger. To give you an example of how clouds get charged and lightning is created, I've drawn this rather helpful diagram. To begin, our cloud begins to move. Pushed by the wind, it begins to rub against the air, just like a balloon against a sweater. Over time, this causes more and more charge to build up. But the cloud doesn't like to have charge. So the cloud begins to look for places to get rid of the charge. But it's not easy, because there isn't any place to give the charge to. Finally, the cloud just decides to give the charge to the nearest object, which in our case is a house. This leaves the cloud with no charge, but the house now might be on fire. Now that we know what static electricity is and how it works, let's create a way to figure out where it is.
To do this experiment, we're going to need tape. Now in this case, I chose duct tape because it shows up really well on video, and duct tape is awesome. But another tape that will work is packing tape. It's clear, so it doesn't really show up so well on camera, but the most important feature of these two tapes is how wide they are. They're both similar in width, and that is the most important piece to our experiment. One piece of kind of tape that won't work is Scotch tape, and as you can see, it's very thin, and it doesn't help in this experiment. Another thing that is kind of important is the thread. We're going to be using about 2 feet of thread in this experiment. And finally, we're going to need some paper and some scissors. We're going to cut ends off the paper, and as you can see, they should be roughly the width of the tape that we're going to be using. There are actually 2 experiments that we're going to be doing with the tape today. The first of which is you're going to take this tape that you have, and you're going to cut about 8 inches off of it off. You're then going to take your thread, which I hung because you didn't want to see all that, and you're going to stick it to the end of your thread. And as you can see, you can now see my thread. And you're going to try not to stick your fingers to the tape as you're sticking it on there, like so. That's about all the setup for that experiment that you needed to do. Now, here's where the cool thing comes in. So you're going to be able to take your strips of paper that maybe you already pre-cut out, and you're going to be able to move your tape. And you'll actually see that only one side of the tape really wants to stick to the paper. If you try to put it on the non-sticky side, it tries to rotate until it gets to the sticky side. And if you use a sticky side, it causes it to pull towards it rather than rotate. So the rotating is more due to the non-sticky side. I already have a pre-cut out piece of tape, but if you want, all you have to do is lay your tape out flat on a piece of paper and cut around it. That gives you a section of tape that looks like this. And again, you'll see the same attraction. The second experiment is much the same as the first, but instead of one piece of tape, we're going to have two pieces of tape. Now, how this is set up is the first piece of tape is attached to the string at one edge. The second piece of tape was actually laid flat on the paper that we have, and then the perimeter was cut out with scissors. That piece of tape was attached at the edge of the other piece of tape, right about so they crossed about where the string is attached. Now, I'm just going to let that float freely, and what you can see is that we created a kind of compass, because only one of the sides of the tape is attracted while the other isn't, and it's going to only point the sticky tape as opposed to the non-stick tape at the piece of paper. Now if I was to put it on the other side where the sticky side is, the non-sticky side is, we get it rotating around until the sticky side points at the piece of paper. If I do that again, it rotates around again. Come on, there you go. And see, it just keeps rotating, keeps rotating, keeps rotating. No, don't rotate back, that way. And yeah, so that's how that experiment goes. So we've created a compass, very similar to what you might see pointing north and south. This one points at positive and negative charges on objects.
Now the question is, why is this important? Static electricity is so common in our daily lives, and we just don't recognize it. Now my challenge to you is to go find things that are statically charged that you didn't think were. Also, maybe find a few more uses for static electricity in your daily life. Shock somebody, or maybe don't. Or you can get dirty and say that you're just testing static electricity. I hope you all learned something. Just remember that science is out there, we just have to go looking for it. And if you have the time, check out some of my classmates' videos that are also on this channel. I'm looking forward to making myself a CD hovercraft.